Hello, guys and girls. The program you are about to hear will be both fun and educational, but it is not a substitute for medical advice. Although we are doctors, we are not your doctors.
Hello and welcome to Travel Medicine. As always, I'm your friendly neighborhood internal medicine doc, Dr. J.
Hey guys, Dr. Santhosh here, pediatric infectious disease doc and researcher.
And let me just loosen my belt in this post-Thanksgiving episode.
Yeah, I had to quite a bit. We had a weird Thanksgiving, Josh. We're Indian, but like from India, not, well, anyways, just, we didn't celebrate the usual kind of Thanksgiving with all the turkey and trimmings and everything else like that. So oftentimes I just ask my kids and I say, hey, let's make something special. It's Thanksgiving. We can make whatever you want. And my daughter goes, can we have stuffed shells? And so I got the stuffed shells pasta, which uniquely like not,
turkey shaped.
Yeah, exactly. And then I said, okay. And then what would you like for dessert? We can get pie and, so somebody did say, oh, well, yeah, I'll get, pumpkin pie. That'd be awesome. And my little daughter goes, and donuts.
I mean, stuffed shells and donuts sounds like the best Thanksgiving meal.
They had an absolute blast, but I have no idea how to. I don't even want to tell them like, oh, this isn't Thanksgiving yet. I just want them to just go ahead and enjoy it.
Well, this is of course a holiday dedicated to overeating.
Yes, yeah. So I guess whatever you overeat is fine,
and also to over drinking.
Oh, okay, yes,
as determined by the quality and number of admissions on the post-call Thanksgiving Day.
Oh dear. Okay,
with
gotcha.
Your standard heart failure and people who put off going to the doctor till after the holiday. Listen,
yeah,
future doctors out there of any stripe, be aware. Take the call on the holiday, not the call the day after the holiday.
Yeah, we have a separate thing in pediatrics, but it's kind of the same. It's, oh, I don't want to take little Timmy into the hospital. It's Christmas. And then, Timmy is hacking and fevering his way through his presents. And then, December 29th or so comes around like, oh God, he's not talking. So.
Tonight you'll be visited by the three doctors you should have been listening to in the past, doctors you're listening to now, and doctors you will ignore in the future.
Yeah. The doctors of holiday present are actually two. And then I guess the past and the future folks can be like one each, but I don't know who they are.
But we've done a 80 plagues around Thanksgiving. We've done a few others, but this year I wanted to focus on one of the organs that does probably the most work out of any during the holidays.
Oh, so are we sticking with the stomach then?
Not quite.
Okay. Intestines?
Nope.
Colon? No, that's still intestines. Bladder? Your bladder gets a nice little workout, and your kidneys? Is that it?
Well, your kidneys are getting closer, but ultimately, Santhosh, you'll have to liver alone.
Yeah, the great cleanser. Yes.
I'm a liver, not a fighter.
I was told that about you. Before I ever met you, I was told that.
Wait, what?
All the way back in medical school, Dr. Ward, one of our good friends, was like, oh yeah, you got to meet Josh. I'm like, oh yeah, he's a good guy. Yeah, he goes, yeah, he's a liver, not a fighter. Turns out he was right. This is completely
wasn't
untrue.
an accent. Yeah, that wasn't an accent related thing.
No,
That's just because Ward doesn't have an accent.
He does not. No, he's been in the United States for long enough. Yeah.
Well,
I think I would love that to be an actual origin story, but I just made that up.
so now that we've gotten all the unnecessary banter, now we've gotten all the necessary banter out of the way.
Absolutely, yeah.
Let's move on to our introductions and then everyone's favorite terrible segues, because it's once again time for our bi-monthly segment. Yes. Everybody's favorite.
Yeah.
Journal Club!
Yay!
And this week, as I said, we're going to focus on the liver, our regenerating organ that does so much heavy lifting during the holidays.
Oh, yeah. So we think about it, of course, when it is filtering alcohol, of course, and reducing the substances that are alcohol down to aldehydes and tearing them apart and making them so that we can pee them out and not be killed by it. But, it's going to process fats. It's going to process sugar. It's going to send out signals for satiety and all these kind of different things. And it's talking to your stomach and your pancreas and your brain and all these other different things.
And most of what it's saying is, hey, stop it.
That's what that pain often is, that that devastating pain that you have. Yeah, absolutely.
So we're going to open with a little bit of a headline that I feel like very exciting, but perhaps a tad overhyped.
Okay.
Wonder drug that causes massive weight loss could also suppress the desire for alcohol.
Oh, wow. Okay. So
sounds impressive, right?
Yeah. I mean, this isn't one of these scary like fen or anything, right?
No. In fact, I feel like the headline is perhaps overselling a little bit of this. So let's dig in. The wonder drug in question is semaglutide, or Semglee, Wegovy, Ozempic, depending on where pharma is direct marketing to you in the world.
Yeah, how you've heard it as a non-generic, like the corporate term or whatever it is.
Yeah, and there's the first issue I take with the headline. Wonder drug that causes massive weight loss. It doesn't. It's not meant for that. It's an injectable drug meant to help manage diabetes. It's a long-acting insulin equivalent.
Yeah. So we have two big proteins when it comes to, well, they're not large, but peptides that our body uses to say, hey, store this sugar for me or release it. So the store the sugar is insulin. That's the one that goes up after you've eaten, and it signals to your body that, hey, you have lots of energy coming in. Please get these into cells and keep them away. And then we have glucagon, which is, kind of the opposite. It raises your blood sugar. It releases all these glycogen stores and glucose and everything to kind of come out. But this is a little bit like, it's different, right? This is a glucagon-like protein. It actually tells your body to say, okay, release more insulin. Let's reduce your blood sugar. But I guess it also has some other stuff with it, Josh, like it slows down.
So it's a synthetic version of the human-created GLP-1, which, as you said, glucagon-like protein, which increases the release of insulin when blood sugar is elevated.
Oh, okay, gotcha. So it's kind of dependent on what your sugar is doing.
It also delays gastric emptying, meaning food kind of sits in the stomach and intestines longer, so you feel full for longer, and therefore reduces appetite. It is traditionally prescribed for type 2 diabetes, but since a known side effect is weight loss, it started to be prescribed off-label for weight loss in those without diabetes, and that actually got FDA approved in 2021 after studies found that obese patients could lose 15 to 20% of their body weight over 68 weeks.
Oh, interesting. this is really important because we have struggled for a very long time with helping people who have diabetes, especially type 2 diabetes, lose weight. Because very classically, Josh, if you get insulin dependent after a while, right? So now you're giving insulin. Well, yeah, that does get the blood sugar down because the sugar gets out of your bloodstream and into your cells. But that also makes you store up all that sugar in fat cells. So you continue to gain weight. It's kind of counterproductive.
And the main reason that this is a synthetic version, it's been modified so it lasts longer. Again, it's an injectable drug. It's not a pill that you're taking. You have to work with needles to do this, which is why, it's not as exciting as or popular as other dangerous drugs like fen-phen and whatever. And again, not designed as a weight loss drug. Just happens to be a side effect, which over a long enough time and with dietary changes and exercise can lead to a pretty significant loss in body weight.
Okay.
Now, interestingly, this same system, the GLP-1 system on which this drug is based, has also been shown to play a role in addictive behaviors, including, and here's where we start linking to our liver, alcohol seeking and consumption. In a 2020 study on rats, because, we always start with rats and nobody drinks like a dirty rat.
Sure. Okay.
Researchers found that semaglutide and liraglutide led to both loss of appetite, but also decrease in alcohol intake.
Oh, okay. Very interesting. I like that.
Now, researchers in Sweden, and I'm quoting a lot of different studies, so I'll throw one or two into the show notes for you, but these are pretty easy to find.
Okay.
And researchers in Sweden found that liraglutide inhibits alcohol's effects on dopamine production, which is, of course, the reward system in the brain. So essentially, people drink less when they're on this drug because they derive little to no pleasure from alcohol.
Oh, okay. Gotcha. So it doesn't give you a nice buzz.
So people derive little to no pleasure from alcohol. Now, that doesn't mean you drink it and all of a sudden it evokes a negative response like vomiting, like antabuse, or you can't take it because it interacts with another drug. It just means, you have your whiskey drink, you have your vodka drink, you have your lager drink, you have your cider drink.
Yeah. Okay.
And it doesn't really knock you down. You don't have to get back up again because you're just like, this doesn't really do anything. So this substance reduced...
Just 2 seconds. Anybody out there who's listening to this, if you have heard of or know of chumbawamba, first of all, don't forget to take your arthritis pills today. And second of all, please let us know so Dr. Josh doesn't feel like he is very, very dating himself.
Is this not what the TikTok crowd's listening to?
I would love for TikTok to bring back Chumbawamba because those two were absolutely made for each other. But yeah.
So this substance, the semaglutide, reduced alcohol consumption by about 30 to 40% in rats that drank large quantities of alcohol for several months.
Oh, okay. So not perfect, but it's always nice to see it working somewhere. Okay, so rats is good.
Yeah, and because it affects the brain's reward circuit, things that you once enjoyed start feeling boring and bland, which not great for hobbies, wonderful for alcohol.
Yeah, that's kind of scary because that's the same... It's a similar pathway like depression. Depression isn't necessarily sadness. A lot of what people will report is stuff that gave me pleasure, that made me happy and excited, no longer do. And this is kind of like that. So I agree with you. As long as you're only affecting the reward system for alcohol, then it's fine.
Well, also appetite suppression.
And appetite, which is good. But I can see this maybe, not going well if it starts affecting dopamine stim for other things.
So that's where they got into some of these studies. There was a placebo-controlled trial that compared it to a dose of exenatide once a week for 26 weeks.
All right.
And patients with alcohol use disorder did not see a significant reduction in their heavy drinking days. But
Oh, okay.
the study did find that the dopamine transporter was lower in the exenatide group compared with the placebo group. So
Okay.
again, the study is centered around heavy drinkers,
Right.
which that's a very subjective way to define what's heavy drinking for one person may not be heavy drinking when we're looking at scientific studies.
Right. But it is nice to see that there's a biochemical effect, even if it wasn't, you have a neurobiological effect there, meaning that you're looking for the amount of transporters kind of available on the surface of the cells. And this is what happens in addiction physiology, right? So X substance, you get a release of dopamine. The neurons on the other side take up that dopamine, and there's a stimulation that makes you overall feel good, happy, excited, rewarded. But after a while, if there's too much dopamine circulating in the system or your brain, the number of transporters actually, right, will, get saturated, so they'll go down, and eventually you get this thing where you need more dopamine in order to feel the same amount of good. So if you're able to affect in some way, so in this case, reduce the amount of transporters there, then that's okay. That's good. But it kind of sucks that it doesn't actually show up as a clinical result.
Well, it also, so again, the people that it works the best on, and the way the study was designed is for heavy drinkers, meaning daily, as opposed to casual or weekend warriors.
Right.
And these drugs have the most pronounced effects on people who are overweight. So
Okay.
if you're a heavy drinker, but, surprisingly fit, probably not going to do a lot for you. If you are a casual drinker and overweight, again, may not do much. So you really have to get in that, for lack of a better word, sweet spot where you are both obese and over-consuming.
Got it. Yes.
However, as many diabetics do end up being overweight, for those in that group who are heavy drinkers or who suffer from metabolic syndrome, this may be a good way to decrease the appeal of alcohol for folks trying to quit.
I see. I understand. So it would be an adjunct, or it would be a helper. It wouldn't be take this pill and you'll be better. It would be this will be an assistance on your way to recovery.
These are lifestyle changes you need to make, and as long as you're on meds, this will give you that extra little boost if you're not feeling the motivation yourself.
Got it. Okay.
So now that we have established you have done maybe too much drinking over Thanksgiving, and
Okay.
if you have been one of these heavy drinkers for a long time, you may have gone ahead and scarred your liver out of its regenerative capabilities all the way into cirrhosis.
Okay. Oh no. Okay.
Which cirrhosis just means scarred. It's a scarred liver.
Mm-hmm.
There was some really exciting studies published in Cell Reports that actually just came out about a week ago, November 15th, 2022.
Okay.
Although this has been explored in the last couple months, I'd say this has been making the rounds. And Santhosh, I'd be very surprised if you hadn't heard of it, because it involves both an infectious disease and an adorable animal.
Yeah. Absolutely. So I'm subscribed to the AAAS, the American Academy.
The Alcoholics Anonymous.
No. This is the American Association for the Advancement of Science. So basically the folks who get together to advocate for higher science literacy and funding for science from government and this kind of thing. And one of their journals is the journal Science. And they send me a beautiful daily to weekly digest of, here's your articles, this week or this day. And one of the highly, highly kind of cited and circulating articles was this really beautiful paper in Cell Reports Medicine talking about, Josh, our favorite cuddly little animal, the armadillo.
Armadillos!
Which, by the way, I love me some armadillo. They're beautiful. They're amazing. If you see them, people out there, No touchy.
They're like huggable little pill bugs that you definitely should not hug. And do you know why you shouldn't hug them?
Tell them, Josh.
Because they have leprosy, or a lot of them.
Yeah, so leprosy is a little bit interesting. It actually likes to grow at a lower temperature than most bacteria that infect human beings. So that means that in that lower temperature, it really thrives. And weirdly enough, Josh, that, that perfect Goldilocks zone for the body temperature where it can replicate and grow and cause disease is around the temperature
is in the balmy American Southwest.
Yeah, and then on the foot pads, actually, the little foot to when they're padding along, the foot pads of the armadillo. So the armadillo itself does harbor this bacteria, and when we're in the laboratory and we need to grow leprosy in order to study it, then the culture media that we use is actually the armadillo foot pad cells.
So a brief aside. Back to the liver. I didn't want you to think we were going to liver alone too long.
No, exactly. Yeah. Although you should liver the armadillos alone.
The liver is one of the organs that is capable of regenerating itself, and we'll go into another study about that shortly.
Mm-hmm.
But a cirrhotic liver, once the liver has become scarred, those scarred portions can no longer regenerate.
Yeah. So your liver, how long is it, Josh? Maybe once every 7 years you have a brand new liver? I can't remember the turnover time for the liver, but the cells are always dividing and working and dying, and we're dividing and working. So your liver is constantly regenerating itself.
About 30 days.
30 days. That's what it is. Thank you. So every 30 days, you get a brand new liver. But liver cells, hepatocytes, can make more liver cells. But after damage, fibrosis, scar tissue, fibroblasts, those are not liver cells, and they can't replicate into more liver cells.
Nor can they perform the basic functions of the liver.
Right. They can't do the filtration. They can't make bile. They can't break down your red blood cells and the porphyrin and everything. So you're just left with scar tissue, and the more scar tissue fills in and there's less area for the healthy liver tissue to grow, it progresses and progresses, and eventually not enough functioning liver, and the toxins kill you.
So what's the armadillo about this study?
What is the armadillo?
Leprosy-causing bacteria can reprogram cells to increase the size of the liver without causing damage, scarring, or tumors.
Wow.
What does that actually mean? I know you're saying wow because we get it, but listening audience...
Yeah, that's true. This
study could be exploited to renew aging livers, to regrow injured livers, which would reduce the need for liver transplant in cirrhotics who have lost a lot of their liver tissue and function. And that's pretty much the only cure for people with end-stage liver disease is a transplant. So if you can regrow damaged liver, or if you can grow new liver out of existing liver tissue to take up the space of the damaged liver, you can avoid a transplant. That does not mean you can start going on a free-for-all drinking binge, but it does mean in people who have lost all of their liver function or enough liver function to severely compromise their health, we might be able to give them leprosy and start regrowing the liver.
No. That's not... Why you got to do that?
Because it irritates you and it's fun. It's not much of a science show if one of us doesn't get to educate. You have to start with the misconception.
This is like the TV show that was like, they get sued because they showed a person putting on a magic cape and flying, and then the little kids like try to jump off their roofs.
Luckily, we're in audio only for now.
Well, yeah. All right. So here, so we've got the bacteria that causes leprosy, Mycobacterium leprae. Okay. The phase of study that we're at right now is very, very early on, where we were actually able to have the observation first that these 9 banded armadillos, when they had leprosy, they were regenerating their liver. But this was an actual controlled experiment with those same armadillos. So they took the livers out, they put the Mycobacterium leprae in, and then they were able to actually see the liver globules and everything, and measure out how many, versus control versus infected, how much liver tissue was kind of regenerated over time. So this is not what we want to do straight up, because leprosy is still a very deadly disease, and we certainly don't.
All right. So
Yeah.
I'll walk back the earlier statement.
Yes, yeah.
These researchers, these professors in regenerative medicine at the University of Edinburgh exploited the ability of this mycobacterium to reprogram cells to grow. So they worked in conjunction with the U.S. Department of Health and Human Services in Baton Rouge. And because armadillos are a natural host for leprosy, that's why they were used as an infection model. And when they looked at the livers that were increasing, because just having a liver that increases in size is not necessarily good. You may see that with fatty liver. That's something we call hepatomegaly. And fatty liver doesn't mean, oh, look, your liver's obese. It means it's turned into a lot of fatty tissue, which is a step on the way to scarring and cirrhosis.
Yeah. So having fat infiltrate the liver tissue is just as bad. But usually if you're at that point, and that does happen to us if we get obese, if we're eating too much, diabetes and liver damage, hepatitis, but it's reversible-ish at that stage.
So despite the increase in liver size, where it is approaching hepatomegaly or large liver status, all these livers, when examined, were healthy liver and displayed the same kind of tissue architecture as normal liver. So it was regenerating, it was getting bigger, but you were not seeing these problems with it. So they demonstrated that liver cells infected with these mycobacteria would undergo reprogramming as a result that reverted them into an immature state, restoring their ability to regenerate.
This is so cool. I actually love where this story came from originally. So they're at Edinburgh, and Anura Rambukana, who's at the university, they were actually using leprosy on Schwann cells, and these are the cells that kind of cover and insulate neurons, right? So they're the insulation for your neuron wires. And they saw that like the bacteria would settle in, and then boom, they would become less mature. They'd look more like stem cells, and they were kind of, hey, what's going on here? What's going on? But then they said, oh, hey, who's got leprosy? Okay, armadillos. So she just gave a phone call. She said, hey, what's going on with your armadillos? What's up with their organs or anything like that? And one of them, just like incidentally, said, oh, well, their livers are always bigger than the uninfected ones. And they freaked out. They're like, oh my God, that's... So that's how the idea came about, and they got to test it.
We'll see if the gene expression caused by leprosy may lead to teaching liver cells how to get a little bit of a fountain of youth, regain some of that vim and vigor and regenerative capability, and then we could use that in order to help treat our cirrhotic patients and decrease the number of liver transplants.
Yeah. Anything that we can do to move away for the need for transplantation is always a good thing. Not just, you have to wish for somebody to either pass away or become brain dead or donate a liver tissue or that kind of a thing. But you're now having incompatibility, and so you have to live with immunosuppressants, all these things. But if you can grow your own liver back, whoo boy, that's the best.
Which brings us to our next story.
Yeah.
Because if you can grow your own liver back, you can pass it on to the next guy. Livers can become treasured family heirlooms because this next study has demonstrated that the liver itself can stay alive and functional for over 100 years across multiple donors and recipients.
Wow. Yeah. This is such a cool story. Josh, tell us about it, but I want everybody to think about, the number of livers they had to go through in order to check this out. Josh, 253,000 livers transplanted between 1990 and 2022. Okay. And they selected 25 of these for this particular study. But yeah, tell us all about it. What happened? What did they do?
So let's learn how you're carrying a little piece of eternity in you. A research team composed of members from the University of Texas and Transmedics Massachusetts have, based on this small but growing subset of livers that have been transplanted at least once and often several times, looked at the cumulative age and essentially which is better, which is longer lived, a liver or, say, an iPhone? And the answer may surprise you.
So just to kind of put this into perspective, so, you've got Joey up in Massachusetts and Leroy down in Texas. And so Joey gave Leroy a liver. Leroy is growing up with the liver, is taking his medication. They're getting all, and then Leroy has a friend, Sally, and Sally goes, "Oh, Leroy, I need a liver." And then Leroy's like, "Well, I got my liver from somebody else, but maybe I can donate this donated liver to you. And, you can get evaluated, all this kind of thing. They're a match." And they're like, "Yeah, Leroy, you could totally donate your donated liver."
So the researchers looked at pre-transplant survival, essentially how long the donor had lived before, their liver became, shall we say, available.
Yeah, exactly. Yeah.
As well as how long the liver, once transplanted, went on to survive in the recipient before it failed or the recipient died or whatever.
Yeah. And now livers are a little bit special, right, Josh? A little bit like kidneys. You can actually donate a piece of your liver and the rest of your liver will regenerate and you can donate it into the person. The recipient will actually grow a new liver out of the donated piece as long as they're both big enough.
And this may ultimately be helped by the armadillo, which I wonder if that'll become the next Marvel superhero.
Yeah.
It's not quite as intimidating.
Yeah. The armadillo?
No, it's Wolverine. Watch out, it's the armadillo. He can heal from almost anything. No. So the lead study author, Yash Kadakia, over at UT Southwestern Medical School, helped to select. So they stratified or selected out these livers with over 100-year survival and identified donor factors, recipient factors, and transplant factors. So they were looking for 100-year-old livers. And in order to find these elderly livers, which wouldn't necessarily be in elderly people, the team used the United Network for Organ Sharing, UNOS, star file to identify these 100-year-old livers measured by adding up their initial age at transplant to the post-transplant survival period.
Very cool. Okay.
All right. Now, how does that happen? Because you're like, oh, maybe if I take a liver from a 25-year-old, that means it's got to go through several people before it reaches 100 years of age.
Sure.
Or one really long-lived one. Most of these long-lived livers, that's fun to say, came from older donors. The average donor age was higher than that of donors for livers that did not pass 100 years of age, meaning the average donor age was around 84 years versus folks that didn't have livers that made it 100 years, and those were around 38 to 40.
So it's a little interesting, Josh. What we're kind of saying is that, you've got, Grandpa Joe who decides to donate a liver at age 80 something through to their, whoever needs it.
Meaning Grandpa Joe can leave you his liver in his will,
Yeah.
and you can make use of it.
Yeah. But what that means is that healthy liver, which was either donated, live because the person was healthy enough to give a piece and send it, or the person became brain dead or something like that, and the liver was taken out as the person was dying. So that liver was healthy enough to donate. I mean, it passed a number of criteria. But interestingly, it also means it stood the test of time. It was still healthy at 80 plus years of age.
My liver went uphill to school both ways, fought through two world wars and a depression.
I would love it if
millennial livers today. No work ethic.
I would actually love it if the 80-year-old liver gets transplanted into like a little 20-year-old hipster, and then the 20-year-old hipster becomes a curmudgeonly, Vietnam vet.
But yeah. The thing is, for all the jokes, that kind of is what's happening, because another notable difference between the groups, the livers that made it 100 years of age came from older donors, and like we said, older, 84 versus 40.
Huge difference, yeah.
Donors from this centenarian liver group also tended to have lower incidence of diabetes, which we really didn't see as much if you're looking at the boomer generation.
Right.
Fewer donor infections, and lower overall levels of transaminases, which can indicate anything from inflammation to years of heavy drinking.
Yeah. So it's... if your liver cells break open, they get damaged. The proteins inside of them that are actually doing a lot of the work are called transaminases. And so if the amount of transaminases is high in your blood, that means liver cells are dying and shedding these into your bloodstream. So now you have to have normal transaminases in order to donate a liver, because that liver has to be healthy to give to another recipient. You can't be giving the recipient a dying liver. But this means that it was just even lower normal than, other folks.
And transplants or grafts of the livers in the over 100 years group, and again, I have to keep saying this, when I say over 100, I mean the liver is over 100, not the person getting it. So no grafts of livers in the over 100-year group were lost to complications of primary non-function, meaning you put the liver in and it simply doesn't take.
Right.
Complications that were vascular related, meaning you put the liver in and all the plumbing essentially doesn't work.
Yeah, okay.
Or biliary complications, meaning you put the liver in and it can't regulate bile to do the things that a liver is supposed to do.
Okay, so some of the most common reasons essentially for the liver to up and die in a recipient. So those didn't happen.
Yeah, these wise elder statesman livers, none of them stopped functioning.
Okay, but did they get rejected?
No significant differences were found in the rejection rate at 1 year between the two groups of transplanted livers.
So two groups meaning the 100+ years and then the young livers.
The standard, right.
Gotcha.
The younglings.
The whippersnappers.
Also, outcomes for the over 100 group actually had better patient survival outcomes and allografts, meaning once the new host died, the organ could be successfully harvested and moved on to somebody else. So, hand-me-downs, heirloom livers.
This is so cool. Josh, this is like when, when folks come over from India and stuff, they bring various things with them. One of the things that gets passed on for a long time is a bacterial culture for yogurt. Right? So we make our own yogurt at home. You take a little bit of that yogurt and you put it into a new batch of milk, and boom, you cook it up together and you get homemade yogurt, because that's the seed. And oftentimes that little culture is passed on from, generation to generation or sent to other households. This is kind of like that. It's so cool.
Now, what this means is this could vastly widen the pool of available liver transplants, because we've traditionally avoided taking organs from older people because, for lack of a better word, they're old.
Yeah. Yeah. The assumption is that the original liver cells that these people had when they were embryos, right? Like they were, turning into fetuses and the liver cells were differentiating. They've undergone so many cycles of replication, and we know that errors accumulate over time with replication. So now you're prone to DNA damage, and ultimately that is, cell failure and or cancer. So there were a lot of people who were excluded because of that. I said no.
So we may be able to start accepting more elderly patients as liver transplant donors.
Mm-hmm.
Or, again, grandparents could deed their livers down. And the reason we really don't know how long you could keep passing these livers around is the very first successful liver transplant was only performed in 1967. That's really not that long ago.
It's kind of, it's weird to think about, right? This is a young
That's
science.
why out of 200,000 studied livers, they were only able to find 25 that met the criteria of being over 100 years old. Because how are you going to find 100-year-old lifetime worth of liver when you only started doing liver transplants in the 70s?
Absolutely. Yeah. It's a young science, and so we have to kind of learn as we go. But it's cool that we can do this now, that we can explore these possibilities. It's incredibly exciting. I absolutely love it.
So let's see. What have we covered over this episode before we move on to our final study? We've learned about a diabetic drug that may decrease your likelihood of drinking alcohol, thus sparing your liver.
Mm-hmm.
We've then learned about deadly or certainly disability-causing bacteria that may help you to regrow a liver that has been damaged by excessive drinking.
Here's hoping. Absolutely.
And now we've also learned of a possible additional source for donor transplant livers. This is 3 great opportunities to, regrow the liver and really advance the field of hepatology. And has a lot of hope for those of us who have spent too much time drinking after being with family during the holidays.
Well, as you mentioned at the top of this, I agree with you that this shouldn't give us a license to just go out and abuse ourselves. We shouldn't be doing that. We can't be getting into a thing of like laissez-faire of like, oh, whatever. We'll just, make a new one or whatever it is. Do imagine, okay, and remember that even if these bear fruit, okay, the actual things that you go through as your liver is dying and getting damaged and all these kind of things, that's horrible. Okay. You're going to feel absolutely wrecked. Not to mention you actually get liver toxicity that messes with your brain, and you'll actually, you could get dumber and all this kind of other stuff. But there's also going to be forever, every person who gets a new liver or we regrow it, it's hard work, it's energy, and it's a lot of love and behind the scenes stuff going on. It's not boom, you snap your fingers and it's a new liver. So let's take some stress off the system. Okay. The best way to avoid all of this is maybe not to wreck your liver, and save these for people where there's no alternative. They have a chronic disease or something like that where they can't help it. That would be a much better thing.
You don't want to drink yourself down to your last 2 brain cells.
That's true too. It's not just your liver that takes those hits, right?
Although,
yeah.
If you do, in our final story.
Oh God. Yes. Yeah.
Scientists are now growing brain cells in labs that apparently can play Pong. This is what we're doing. That's some scientist out there. Researchers have grown brain cells in a lab
Yeah.
and taught them to play Pong.
You just decided to throw that segue the hell out the window, didn't you? Just that was so good.
Santhosh in a lab.
Yeah.
Dr. Brett Kagan,
Yes, and et al. Yeah.
working for the company Cortical Labs,
Uh-huh.
publishing in the journal Neuron, has created lab-grown brain cells. Not a lab-grown brain. Cells.
Yes. Cells. Right. Yeah.
Small plural.
Well, and you're right. There isn't a whole brain in here, but it is considered an in vitro neural network. So
in vitro meaning essentially a bunch of petri dishes.
Right, exactly. Vitro meaning in glass. So, yeah.
I know this doesn't really relate to the liver, but I don't know if I'm excited or horrified that people are just growing brains and teaching them to play 1970s video games. So
Yeah.
mini brains, as they're called,
Or organoids. So these would be neural organoids.
first were produced in 2013 in order to study microcephaly, which is a genetic disorder where the brain is too small.
Mm-hmm.
And these organoids have produced in a bunch of labs and have been used for research into brain development. But prior to this study, no one's ever tried to plug into or interact with the organoids. They're just say, let's see how this organ functions. Now, again, one of the things that makes this mildly less horrifying is no one is trying to claim that these brains are sentient.
You're correct. You're right. They're not generally intelligent. They're not able to seek.
But then again, they're playing a video game. You have a little brain in a jar.
Yeah.
Don't argue semantics with me.
I'm sorry.
You have a brain in a jar playing a video game.
Well,
that's what we humans have created. That's what we're up to now.
They were programmed to. Yeah, they were actually built specifically for trying to play this video game. And, they were terribly good at it.
Oh, I'm sorry. Did the ability of a lab-grown brain to play a game that was the height of entertainment in the 1970s not impress you? Because they grew human brains from stem cells and mouse embryos to a collection of about 800,000.
Yeah, so that's a teeny tiny. You can see that as it looks like a little cell layer in a dish. Yeah,
and they connected this mini brain to the video game via electrodes. So they plugged it in.
Well, they grew the cells like in a layer on top of the actual chip, like on the silicon chip.
And the electrodes would show which side the ball was on and how far from the paddle. That's it. That's the whole programming.
Yeah. So exactly right. Yeah.
The cells then produced electrical activity of their own. It's not like the researchers were saying there, okay, here's what I want you to do. They just grew them on the plate, turns the game on, and then the cells started playing. And here's where it gets exciting or horrifying, depending on your feeling about this research.
Okay.
As the game continued, the cells expended less and less energy to keep it going. Except when the ball passed a paddle, meaning one side lost,
right,
and the game restarted with a ball at a random point, you would see a burst of activity indicating recalibration to a new situation, and the mini brain would then learn to play under the new circumstances within 5 minutes, with its success rate statistically well above random chance.
Right, and there was 2 groups, okay? So they took Dishbrain, that was the name of the...
And my new favorite insult. Listen here, Dishbrain.
Yeah. So they named it, Josh. They gave it a name. They called it Dishbrain. So they gave it sensory information, which in this case, the sensation was actually the electronic location of the paddle and the ball. So that was basically, this thing couldn't do anything else. It sensed where the paddle was and where the ball was. Like that was its only stimulation. And then they gave the dish brain either feedback, right? Saying that they just said, oh, okay, the ball went past you. Okay. Negative feedback. Or, oh, you hit the ball. So you got a good feedback kind of a thing. And then they did have another control where they didn't train the brain at all. So they didn't give it any type of stimulus or feedback or anything else like that. So then what they did then was they actually, stopped the feedback. They let the brain just play by itself. And they found that in that case, the stimulated brain, the one that would have been taught and started to learn, actually started to utilize that information and play better.
So dish brain doesn't know it's playing Pong.
Yeah.
It's simply responding to it. But when people look at tissues, at the moment, they're just seeing if there's activity or no activity. But the purpose of brain cells is to process information in real time.
Yeah.
And teaching dish brain to play Pong may one day be used to test treatments for other neurodegenerative diseases such as Alzheimer's. How few brain cells can you have and still achieve learning or function in terms of feedback? Or, can you teach areas post-stroke or in Alzheimer's or others to learn and rehabilitate faster? Or maybe you could grow Terminators. Really?
Yeah. Yeah, only because the Terminators,
Okay.
back.
You laugh, but
No, I know.
no. Listen, Santhosh.
Okay, I'm listening.
You laugh at me and my distrust of AI, but Dr. Kagan's team is specifically working with bioethicists to ensure they do not accidentally create a conscious brain.
Well, yeah, you do have to. The chances are really small, right? Because especially in a system
never zero.
Well, they're never zero. But in a system like this, especially because there's a physical restraint on how these brains can grow, right? There's a tiny dish. Like it can't grow. Our brains need to actually have physical space in order to grow to the size that they are and have enough neurons and everything else in order to, make the complex system that is a human. You're keeping it in a little dish. That's just the start. But you're also giving it a very narrow set of parameters, which is, we'll call this thing paddle and this thing ball, and stimulation will be ball hits paddle. Like it's very thing. But I do agree that this is kind of the beginning of something, and it's not really the beginning either, because as you said, we've been working with brain organoids for quite a while. And I think more and more as we do this type of a research, we're going to have a tight relationship between scientists and students of humanities, like ethics and philosophy and that kind of a thing. Because as we make these systems more and more complex, by the way, whether it's living brain cells or whether it's thinking computers that are pure silicon, there's going to be some point, you're absolutely right, Josh, where we get damn close to what we consider sentience. And in that case, we're going to have to know ahead of time what to do so we're not taken by surprise.
Now, I think one of the things that the bioethicists are doing is if it gets too close to sentience, they're going to show it, I don't know, TikTok.
No.
They'll introduce them to Tide Pod challenges. I don't know how they're going to protect us.
Well, the Tide Pod is closer to what you're talking about, because as I said, this is just a tiny little dish.
Hey,
so you just
dish brain.
a
You want some detergent?
a little bit of bleach, and it's gone. Like it's literally just absolutely toast. So
I'm melting.
oh no, not like that. No, that's you're not. No, you're not destroying a sentient thinger. You're just,
That's how it starts, Santhosh.
So, Josh,
welcome our robot overlords. No,
just to let you know, in composite, like how long the brain took, it learned in about 5 minutes.
yeah. Without being taught, it simply said this paddle, this ball, and the brain and dish brain said, "Oh, if I keep making ball hit paddle, I keep getting feedback." They didn't say these are the rules of Pong.
Right,
they said, here's paddle, here's ball. Dish brain said, "Ooh, Pong, Pong, Pong."
Yeah. So about as long as an average 8-year-old in 1972 would take to master an Atari console. And now
your average 70-year-old learning to use an online app.
Sure, absolutely. So, and it, of course, it wasn't as good as we would think it to be. It did often miss the ball, but the success rate was just much, much better than chance, essentially. It's like like if your 3-year-old little brother or sister found your Atari paddle and just started,
So that's it for this week.
Oh God, we just scared the shit out of everybody.
I don't know about you, Santhosh, but I sure could use a drink.
Yeah. That's all right. We'll get you a new liver. It'll be fine.
We've got 3 ways to do it. So that's it for this week. As always, we love to hear your comments, questions, and feedback. Thank you so much to all of you supporting us on our new Acast Plus platform.
You guys.
With conversations that go nowhere. If you'd like to subscribe, you will no longer hear the ads that have finally started playing. I'm also going to work on better transitions into those ads. Until next time, wash your hands, wear a mask, get your shots.
Don't touch any armadillos. Yeah.
Don't touch armadillos. Do not drink enough to destroy your liver. Drink responsibly. And when you've done all those things, find a country that's open. Grab a friend to go with. And happy travels.
Bye, everybody.